Okay, so in this video, I'm going to go over a little bit more on connecting into the server, in case you're still having trouble with that, some of the basic Linux things. And I'm also going to go over the first homework problem that was assigned. Okay, so that was about arrays. So arrays you should have covered in the introduction to C++, and it's the first data structure, is really the only data structure that you hit in C++. If you do strings are kind of data structures, but that's more of an advanced topic in some ways. Okay. So we're going to go through the basic idea. So I'm on a Mac, so you can use the terminal on a Mac, or I've downloaded this program called Warp, which is free. If you have a Mac, it's a really good terminal program. And I would do the command here I've got at the bottom here, SSH into your username, okay, at ludwig.mcs.uvays.edu, okay. I could also just connect SSH into the ludwig.mcs.uvays.edu. If you do that, your login name is just that first part. So for me, it'd be def3qu. It doesn't include the @ doesn't include any of the other stuff, okay? And if you're on a Windows computer, you'd be using PuTTY, P-U-T-T-Y. You can search for it and do a free download, and then you connecting to ludwig.mcs.uvays.edu on port 22 for SSH, okay? So, why not really there? There we go. And once you log in, you'll notice that nothing shows up. So when I'm typing in the password, it doesn't let you know that you've done it. So you just type it all in. If you make a mistake, you can backspace over it, but you can't see it. You can't even see that anything is happening, okay? And the reason for that is it's a security thing, in that if somebody's looking over your shoulder, they can't see how many characters you've typed in. They would have to count the strokes or something, okay? So once you're in, you come into the machine, okay? If you do a pwd command, it tells you where you're at. And I'm at here, my home directory. Everybody has a directory in the home directory, and then my username is next, okay? And then the other thing we can do is an LL, which is a long list of files, and this shows all of the stuff I have in my directory, which is a bunch. You won't have much at all, okay? But I do have, if you look here, this CSC 2180, which you should create. You create that with the mkdir directory, and then we're going to change into it with the CD space CSC 2180, okay? And again, you can see on this little listing here, if I can highlight it, Linux tells you a lot of information. First, it's a directory, okay? And then everyone can see this, so there's no other way around. This is me, I always get this wrong. I have read, write, and executable directory access because directories need to be executed, oddly enough. And then the groups, which we don't use, also read, write, execute. Other folks, okay, if you could get to this directory, which you may not be able to, would have read and execute, but not write, just how it's set up by default, okay? This is the owner, okay, which is me, and the group, which is also me. Directories have the same size. We see other files here. For example, this days.cpp has a size of 336, okay? Then it's the date it was last modified is the next thing, okay? The date and the time, okay? Just to give you an idea as to what's going on. Okay, so let's do a CD into this CSC, and notice on the server, if you hit tab on most systems, on mine, I just have to click over it, connects it. Oh, tab should do it. That's weird. I guess there's more than one. Tab often doesn't autocomplete, okay? So when I go to the CD space CSC 2180 and hit return, notice for one thing, I see that up here, I'm at tilde/CSC 2180. And in Linux world, tilde means your home directory. So tilde is the same as /home/def3qu. Again, another pwd shows that in fact I am in the home def3qu and then CSC 2180. Okay. So from here, I have a bunch of stuff which we'll be covering as we go along. But the thing here, I have an intro directory that I've created. Okay. If you look at the files here, I have some random things. There's a search program here. There's a hello program. But the one that I'm interested in first is this. This was the homework, the arrayProgram1. Okay. So I'm going to look first. This is also just an introduction to the way I like to program things, so you can get an idea. Okay. So we'll start here, and that we're including the IO stream and then using namespace standard. You don't have to include namespace standard every time you do a CN and out, CN and C out. You could do a STD : but I don't like to do that, so I put that there. Okay, I have my int menu function, which I'm going to use in a minute. But if we start int main, okay, it's an integer function. I like to return 0. If not, then that's not correct. It won't complain, and it should. But that 0 just means that things are fine. Okay. And then as far as setting up the menu, that's the first thing. So I've created this little program that does nothing, a little function that does nothing, but display the menu on the screen, have the user pick a choice, return that choice. Okay. And the reason we do functions in general, so the whole idea of functional decomposition is that you're going to break the program into logical units that just make more sense. So to have to ask for the menu a bunch of times within the main program is pretty cumbersome. If you want to do it that way, I'm not going to take points off. It doesn't matter. Okay. We're going to see another minute where in a minute where I could do more functional composition. I'm choosing not to. Okay. So in this case, I'm just doing a C out. If you haven't seen it before, the / tab T here is a tab character, make it look a little bit better. And the \n is a new line character. Okay. I could have also have done, as I do other times, like down here, this endl is the same thing as the \n. Okay. So I'm printing it out, and then I'm printing out the 2 here. So there's 2 lines after this. Okay. And then another tab, and then I'm just doing this little equals greater than, then a couple of spaces for where I want the choice to come in, but no new line character. And then I'm doing the CN on the choice variable that I've set up here as an integer. Okay. And I'm doing some basic error checking here. We really should do some more and let them stay in the loop. That would be a better program, but for this one, I didn't do that. So I'm just saying if the choice is less than 1 or the choice is greater than 4. So they've selected something that's incorrect. Okay. I'm just going to set the choice to 4 and exit. Okay. I'm not going to give them an error message. I probably should, but I'm not. Okay. The thing I'm not checking for here is if they enter something that's not an integer into this choice, then it's going to blow up, and we'll get to exceptions later to deal with that. Okay. So whatever choice I get, I return the choice, and that's it. And then back in the main menu, I have some things to set up. As the program says, there should be a variable of 100. Okay. So you'll see in my next version of this program, I've actually replaced this with a value integer variable called length, just to make it more flexible. But in this case, I'm setting up my array. I'm setting up the index, which since we're adding to an array that's not full, we're going to keep track of this index. So one of our options is to add new items to the array. So a new item to the next position. Okay, so I'm keeping track of that current position with an index variable, which I initially set to the initial value of 0. Okay. And then I've got a choice here as well, because the choice is going to come back from the menu function. Okay. So I need an initial value of choice in order to be able to get into the while loop. Okay. So I'm setting choice equal to 1. Doesn't mean anything, so I'm going to ask for it immediately. Okay. And then I'm saying, well, choice is not equal to 4. If choice is 4, it's an exit, and I just return, the program's over. Okay. But if choice is not 4, I'm now going to let choice be equal to what gets returned from the menu function. Okay, so menu will ask them, display the menu, ask them through 1 through 4, and that will come back here. As long as it's a 1, 2, or 3, it'll make it here. Again, if it's a 4 that comes back, you never even get to this line. Okay, you could do multiple if else statements here if you want. If that makes you happy. I just did a switch. Okay, so I'm doing a switch because I only have 3 options. There's a 1, 2, and a 3. Okay, and for right now, since this program's just kind of specking out what I want it to do, and this is the way I tend to program, I've got case 1 just prints out, add items to the array. Okay, remember you need a break if you're using a switch statement. If not, it would keep flowing down. Case 2, so that means case 2 means if choice is equal to 2, I just print out array, then a break. Case 3, search array, break, we're done. Okay, so that's all we have there. So one thing about the programs that I mentioned in the assignment, I think for next week, I expect these programs to be working, okay, at least running, okay. Any program that doesn't run won't compile, in essence. You get a 0 on, okay, because I want to encourage you to get it running. So if I wanted to actually compile this, I would do a G++ space -O to give me the name of my executable. It's going to be array program basic program one, sorry, program one, basic structure.cpp, but I want to make that .exe, okay? And then I want to call the program I want to compile. So again, the executable goes with the -O. -O is an option. This option for the output file comes in there for the name, okay? And then what I want to compile is the array program1 basic structure.cpp. Okay, that order is important, okay? Runs, no problem. I can do a // array program1 basic structure.exe. Okay, you need the / because Linux only runs things that are in the root path. Your current directory is not in the root path. So the / says to look specifically in your current directory for the file. Okay, you run it and you see that it does pop up the menu item. Okay, and you can test this out. If I do a 3, it just prints out a 3. 1 prints out a 1. 2 prints out a 2. A 4 should exit, and it does. And to test it again, let's put in a 66. It also exits. Okay, so I think we're okay. So now let's look at the complete version of this program. Okay, so you see the menu here is still unchanged. Okay, I do have some more variables here. Okay, so again, as I mentioned before, I've set up a length equal 100. I've set up the int array then based on the length. Okay, I've got my index equals 0. I've got a choice, which we're switching on, okay, which we had before. I'm also using an int item. When I search for an item, I'm going to use that item. And when I input an item, I'm going to use item as a variable to store what I'm going to add to my array. Okay, and I can reuse those. You can make those separate variables if you like, doesn't matter. I also found in the search program, it's easier to set a Boolean. Booleans are either true or false, and then print based on that rather than try to get the print statement in the right spot. Okay. So as before, this top box are all the same. But now let's look at what's going to happen here when we're adding item to the array. Okay. So the first thing we have to worry about is whether or not there's room to add anything to the array. So in this case, I've got a comment, the // just as a comment. Array is full when index is equal to length -1. Okay, so if the length is equal to 99, valid array addresses are 0 to 99. Okay, so if it's equal to 99, it's full, and I'm just going to say can't do it, break, done. Take us back. Okay, this program doesn't have any way to delete it, so we're kind of done in this case. Okay. If we get to this next comment, add new item to the array and increment the index, then we've made it. Okay. So, I think actually not. That is not going to work. I didn't test that. I need an else if here. Okay. Or an else. Because, and if you're the tab character will fix your spacing if you want. Yeah, I need an else there because if that one happens, the other one shouldn't happen. Well, it shouldn't matter. The break may solve that. The break would solve it. I don't need that. That's okay. I think it would have worked otherwise. But what you don't want, I didn't put in enough numbers to make it full. Okay. And to test that, I would probably, if I were going to turn this in, change my length temporarily to 10 so you can check to see that it works for that one. Okay. So I'm not sure that's 100% necessary, but it'll work in either case. Okay. So anyway, now we're going to ask the user to enter a new item to add. We're going to use a cn to add that whatever they've typed in to the item variable. Again, we're not checking to make sure they're really entering an integer. We need an exception for that. So that's a issue to address later. But then I'm setting the array sub index equal to the item. Okay. I'm then increasing the index by 1 with an index ++. Okay. So that's all that choice 1 does. In case 2, I'm going to print out the array. Pretty straightforward. I'm just going to loop again, I'm going to do an int I inside of the for declaration, which means it's local to that loop only. For I equals 0, I is less than index. Okay. You want the I being less than 100. So it's going to go from 0 up to 99. I plus plus. Okay. And then you're going to, no, sorry, it's going to go 0 up to the index, which could be as big as 99. You don't want to print all the way to the length because it would print, I think the new versions of G++ set those to 0, but they're not, if the value of them is set, we don't want to print them. So we want to use the index there. Okay. So then we're going to see out the array position and then indel. You can put a tab between them, space between, whatever you want. You have some options there. Okay. And then we're going to break again. And again, the break means we go to the end of the switch statement, which is why I don't really need this else. I forgot about that. Break will take me out. So I'm going to go ahead and get rid of this. One thing I'll tell you, if you haven't used Emacs much before, it does try to automatically format things for you. And if you find that it doesn't format like you think it should, there's probably a syntax error. So it's worth checking. Okay. So that's the printout, what it looks like. In case 3, we're going to search. Okay. So I just print out what the issue is here, what we're doing, and then enter the item to search. Again, I'm not checking that it's actually an integer. If it's not, this is going to blow up, but we'll deal with that later. I'm going to go ahead and set my found equal to false right here. Okay. I've initialized found as a Boolean up at the top. I'm going to assume it to be false. You can assume it to be true. It doesn't matter, but I think it's easier to assume it to be false. Okay. I'm now going to go through. And for int I equals 0, I was index less than index like we did before, I plus plus like we did in the print. I'm going to check to see if the array sub I is equal to the index items that we're looking for. If it is, then found becomes true, and we're going to break. The break should get us out of this if. And I think actually the break is in the wrong spot there. I think if the break were outside of the if, I wouldn't have to go through every item, which it probably is going to do as it is. So that's a tweak that you can improve. It works, but that could be improved. Okay. And then at the end, if found equal true never hits, it should still be false. So I can just say if found. Remember, I can say if found is equal to true, but that's redundant. Found is either true or false. So I'm just saying if found, I'm going to see out the item and that it was found. If not, I'm going to see out that it was not found. Okay. So yeah, I think it would be more efficient to move that break outside of the if, so it breaks the for, not the if. In fact, I'm going to go ahead and do that because it bothers me. And this just shows, I mean, you write a program, you get it working, and you find that it can be improved. Okay. A control K is what cuts, and then I can do control Y to bring it back. Okay, and then hit tab a few times will reorient where things should go. And I think that should work. And again, visually, because I've hit the tab key, this closing bracket goes with this opening bracket. And that one goes with that one. Okay. And this is not inside of the if, it's outside of the if. Okay. So I think that should be more efficient. And that's all it does. Okay. So let's run it, see if I've broken it. It's always possible. So I'm going to do 2++ -O. Again, the executable is going to be the array. The executable should have the same name as the program typically. And then arrayProgram1.cpp. Okay. Run it. Seems okay. /arrayProgram1.exe. Gonna run it. So let me add here. I'm gonna add a 1. I'm gonna add a 2. I'm gonna add a 3. I'm gonna add a 4. I'm going to add a 5. Okay. I'm going to print out what I've got. 1, 2, 3, 4, 5. Looks good. Okay. I'm going to search the array first for something that I should find. Let's search for a 4. Okay. And 4 no longer works. So I've broken my program. It worked before. Okay. Let's see if I've just got the opposite problem. So let me search the array again. We search it for a 8. Okay. So I've broken it so it never finds anything. So I need to go back and fix that. I won't bother you with that, but yeah, something in moving that break, I've got an issue with the not found never being, or it's changing it back somewhere. So it must be looping back again. Okay, so look at what I did before, not what I did the second time. Okay, and let's see if the exit works. Exit works. Okay, so not perfect, not beautiful, but you get the idea. So let's look real close at that code to see why we think it's not finding things that are really there. Okay, so that's going to be, in our case, item or index 3 was equal to 4. So we're down here in the search. I'm getting my found equal to false. Okay. And then I'm saying for int I is equal to 0 on there. And that should be true. Found is equal to true. Yeah, I'm not sure why it's not, why that's causing trouble. It's very curious that it worked that way. And there, I'm just saying if found, so found is getting reset somewhere. And I'm not sure where. Just a tip, okay? I'm gonna go ahead and do a C out here just to see what my program's doing. And this is, we'll call this a learning moment. I'm glad that it happened. So I'm usually gonna put something wacky in my print statement because I know I want to get rid of it later. Okay, so I'm gonna print out the item when it gets here. Okay, so now when I run it, I'll know that the found should be set to true. That way I know, is it never getting there, or is it getting there and being changed again later? So let's see. Up arrow should let you do your program things again. Do that. Do that. Okay. So I'm gonna do a 1 is a 1. I'm gonna add a 2. I'm gonna add a 3. I'm gonna add a 4. I'm gonna add a 5. Print it out. Looks good. Okay. Now I'm going to search for that 4 again. Okay. So this tells me, for whatever reason, it's never making it to that. Okay. So not sure why it's true. Take another look. Okay. So I've done something to mess things up. I'm pretty sure it's working before. Unless I'm insane, which happens. Okay. So this is never being true. So let's go ahead and print out here. See out. Again, something crazy. I want to print out the item. No, I want to put out array sub I. Put a tab character and item. Okay, just so I can see, kind of track down what's happening there. So do 1, 2, 3, and I'm going to search for 2. Okay. So the first time it does it, oh, my loop's not working. The break is happening too soon. Okay, let's test that. Let me do a search on a 1. Oh, that's the wrong thing. Let me add a 4, it doesn't matter. Let me search for a 1. 1 is found. Okay, so I found my problem now, right? The problem is it's not looping for whatever reason. So I broke my loop. Take a look at the code again. Okay, so we're down in 3. That it is the break. I see now. The issue is if it's not the first item, it breaks out this loop. So I can't do that. I can't put it there. Okay, so I do have to put it back where it was. Okay, so Control A takes me to the beginning of the line. Control K. In Linux, it's kill and yank. Control Y. The tab key to get back in place. That should be fine. And now I can just comment out these lines at the moment just to see if they work. See, sometimes second guess yourself. It's a bad idea. Do 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Print those out. Good. Let's search for a 4, and 4 is found. So we fixed it. Okay. So hopefully that made sense. What all the issues were. This is still going to have, I think there's still an issue here, that it's going to go through on the search through every item. So let's think about that. Okay. But I think it means I don't need to break it all there, now that I think about it, because it's going to come out of that, hit the other break. So I'm not going to mess with it because it's working in that sense. But what we want to do here, if we hit this item and set found to be equal to true, we don't want to go around the loop anymore. Okay. So we need a conditional break there, I think, is the issue. And I'm pretty sure that's the wrong spot. So let's just kill this one. Let's be bold. So I think I can say if found break. Okay. And I can check this because I can put in this for loop a cout, again, just with some garbage, just so I know how many times it's hitting this loop. Okay. So let's go ahead, run it again. Do 1, 1, 1, 2, 1, 3, 1, 4, and 1, 5. I'm putting them in order, but it wouldn't matter. That works. Okay. So now if I do a search on a 1, it should only do that one time, and it found it. It's correct. Okay. If I do a search on a 5, it should go through every time. And it does. Okay. A 4 to exit. Oh, one more thing I didn't check. Let's do a 1 for 1. Let me search for 55. Not found. In this case, only one item, it checks one time. Okay. So I think we're good, unless I introduce new errors, which is sometimes possible. Okay. So this turned out to be a little longer video, but I think it's worthwhile. Okay. I think it's told us some valuable information. So now that I know that it's working, I can go back to my case 4 and I can be bold and kill that line, kill that line. Okay. Feel pretty good about it. Okay. So the other thing I want to talk about is this coming week. Okay. So this coming week, we're covering a bunch of chapters. A lot of it's review until the end. Okay. So we're going to be covering classes, which you should have seen, inheritance, which you should have seen. We'll talk about abstract functions, pure virtual functions, all that stuff. And then at the end of the week, I know it all hits at the same time, but at the end of the week, you should be hitting linked lists. Okay. And there's a fairly sizable programming assignment. I think there are currently 12 programs, but I'm going to take, and when I've taught this in the past, I've split up the linked list a bit more. So I'm going to take the last 2 programs out of the current assignment and move them to an assignment for next week. Okay. So if you read the program list before I get to it, only do the first 10. Okay. The linked list are where we get really into the first data structure we're creating ourselves. Again, the first one that you use are arrays, but arrays are built in for us. Okay. So this, the linked list will be the first one we create ourselves. Okay. There's a video for that. For all of these, and I may do a video where I show this. It's important to draw these problems on paper with pencil or using Notability or whatever app on your iPad you want to use, because it's hard to see where all the pointers are going to go without a picture. Okay, so I would encourage you to do that when you're stuck. Okay. We're also, I don't think I mentioned, we're also covering pointers. Of the things that we're covering, pointers are essential to understanding and to being able to create the data structures that we're going to need. Okay. So if you're weak on pointers, make sure you watch that video. If that's not enough, lots of good resources. There are YouTube videos about C++. There's a C++.com, spelled out C-P-L-U-S, C-P-L-U-S.com. There's Geeks for Geeks, lots of places. Okay. This class moves fast. It's a summer class. They're super condensed. Don't get behind or you won't catch up. Okay, so if you have questions about any of this video that I just did, or any of the homework or any of the readings, make sure you let me know. Okay, this course demands a fair bit of work. I would not be surprised if you spend 3-4 hours a day, every day on this class. Okay, just how it goes in the summer. Okay. Anyway, if you have other questions, make sure you let me know. I've only heard from one of you about lab times, so I'm not sure. We'll see how that works on when we're going to proceed with having a couple of labs a day. Okay, so if you've not responded to that, please respond as soon as you can so we can get that set up. Okay, more videos to come.